Okay, so let's discuss the results for the situation 1, where you are where you should create an entity relationship model for the following situation. I'll read it out loud, so it's also on tape. So a student has a name, a student identification number, and an email address. In every semester, students can take any number of modules. A module has a name, an internal ID, and a short description. Every module is held by one lecturer. A lecturer can have any number of modules. Every lecturer has her own office. Okay, that's the verbal description, and that's very often the case that when you create such a model, you can verbally express what's happening and what should be modeled, and the task now is to transform this into a more formal model using the entity relationship notation. So who wants to start and tell me what you did?
We said that we have the entity student, module, and lecturer.
Okay, we need to go slow. So what's the first entity?
Student.
So you have student. And since it's an entity, we'll put a square around it, and then you have another one.
The module.
Okay, I'll put it on this side, module. Okay.
And then there's a lecturer that should not be too far from the module.
Okay. I'll put the lecturer down here. Okay, that's the entity types. I think it's rarely visible, but maybe it is.
And then the student has different attributes, like the identification number, the email, and the name.
Okay, I'll try a different color. So identification, I just make it short, ID. So you put that in an ellipse.
Email and name.
Okay.
And we have a relationship from the student to the module that the student can take the module.
Okay, a relationship between student and module, which says a student can take a module. Okay, so how did you name that? Can take?
Yeah, can take.
And then we put this symbol around it and connect the two. So the colors are not necessary. You can do it all in one color, but I'll just do it here so we can distinguish the different types easier, and maybe hopefully it will be visible on the board. Okay, so student can take a module. So maybe does anyone else want to continue, or do you want to continue? Maybe you can continue, and then the others can add or correct if you have anything.
The module has a name, ID, and a short description. So three attributes: name,
ID, you said, right?
ID, name, and short description or description.
All right.
And in the task, it was said that every student can take as much modules as he wants. So we have the N-to-M relationship.
N to M.
Yes.
So that means, if we read it out loud, any number of students can take any number of modules and any number of modules. So any module can be visited or taken by any number of students. So that's basically how it's in reality. What if we changed it to 1 to M, just hypothetically? So what if we wrote 1 to N? What would that mean? Yeah, so you would have any module can only have one student. That wouldn't exactly mean that, and it would mean that one student can still have more than one module, but it would only be one student per module. That would be very insufficient and also boring. So That's why we have n to m, and the 1 to 1 is even worse here. So then that would mean that we would have only one student per module, and one module can only have one student, and so that wouldn't make much sense. Okay, so n to m is what you chose.
I have a question. Can you enter or can you describe limitations with this module? So, I don't know, for example, in this module you can't have more than 24
Yeah.
students.
Yeah, there's an extension, or there's actually a notation for that, where you could say, okay, there's n or m, but well, you could say something like 1, and I don't know the exact notation, but it's something you could say max and min. So you could say a minimum of 1 or 0, and a maximum of 24. So you could say that. I have to look up the exact notation, but it's possible to do that. I left it out here because it's rare. So I rarely encountered it in practice, but it's actually relevant. But usually, what is done often is it's left out of the entity relationship model, but you model it later on in the database. So but it would, of course, if you know it in advance, be the right place where you model it. So if you know it can only be a certain number, then. So this might apply to the number of students per module, right? So if you say we have a maximum number of 30 students per module, then we could put that in here. Okay, so you want to continue, or is someone else?
Yeah, we can.
Yeah, go ahead.
The lecturer has an office, so it's an attribute for the lecturer.
Okay, so you have an attribute office. Does he have any other attributes?
Well, in reality, we should certainly have a name or something like that.
So
According to the situation.
let's grant him or her a name, at least a name. So that's so if it's not explicitly in the verbal description, but you can assume that you need it, so then just put it in. So that's a good hint for the case study. There is going to be a lot information that is also missing, where you might need to put something in. So if you know that a lecturer usually has a name, it doesn't make any sense to have a database with only his office or her office, put in the name. And maybe personal number, I don't know, staff number or anything. You can use your imagination, but name is definitely sufficient here. Yeah.
And then modules are held by a lecturer.
Are held.
They're held by.
Okay, and let's use held by. Makes it a little bit.
And the situation says that there's only one lecturer held in one module, so we have the n-to-1 relationship. So
N here.
n-to-1, yeah, exactly.
So
This means that the module is held by one lecturer, but one lecturer can hold different modules.
right. So one lecturer can hold different or more than any number of modules, and any number of modules is always held by only one lecturer. So you can read it both ways. So is there anything else? That's the whole model? It's not. That's it, right? Okay, so maybe one remark. When you think about, so we're doing this because we want to create a database later on. It's always a good idea to have an identification in some way. So we call that later on is the primary key. We learn about that when we talk about databases. So there should always be, for every entity type, an attribute that identifies a particular entity from that entity type uniquely. So it's often simply an ID that we generate. That this could be a technical number. So for example, your student ID. Basically, it's a technical number. It doesn't have any meaning. I think there is even a meaning. So starting with a certain number, you can identify what year you're from or stuff like that. But basically, it doesn't have to be a meaning. It just has to be an ID that is unique for each entity in that entity type collection. For module, we have a unique ID in Oscar, and each lecturer should also have a unique ID. It should be the staff number or whatever. So It's always necessary to have that. If you forget it in the model, you will have to add it later on anyway. So always think about it. And then when you already know that that's the one unique attribute, you can already underline it. And that is, I forgot that in the slides, but it's the way of expressing that this is a primary key or a unique attribute. So there's no student with the same ID. So with the same ID, that's twice in the data. Everyone has a unique ID. The same goes for module and for lecturer. And if you know that's the attribute, then underline it so it's clear. Okay, so are there any other suggestions regarding situation 1? Did someone do something differently? Do you have any remarks or questions? So there's one. Yeah.
The office also an entity instead of
Yeah. So you said if the entity, the office could also be an entity. I just wanted to say that. So you could do that, and so then we would have office down here, and some relationship between. And what would be a reason why we would model it this way?
because it's an object office.
Yes, that would be an argument, but why would it be an object for us rather than an attribute?
Because we can maybe also what was the name? Just 1 second. Yeah, because there's a cardinality between. So if you have one lecturer, and so there's one office.
So you would have a one-to-one, first of all, right? So one-to-one, and that's the one that I said is rarely used. But here in this case, you could model it as a one-to-one relationship between the lecturer and the office. But again, this is as right as this one is. So there's both are possible, both ways. But there's a distinction, and we can maybe reason about why we would rather do that, or in which case we would rather do that. Can you imagine what that is? So you already, I think you went into the right direction. So if to us this is an object with more than just the office number, with maybe different attributes that are relevant to our model. So for example, maybe the size, maybe the building that the office is in, maybe even the equipment that's in the office. If you want to model, maybe we have a larger model that says, okay, an office has equipment. Right, so equipment that students can rent, or I don't know, just imagine. Then it would be necessary to model the office also as an object. If it's just to know where the lecturer is, and you just want to know that one detail, which is the office number, basically, then there's no need to model it as a separate object. But if you have a requirement and have something more to model here, and maybe even a relationship with another object, then you need to model it as a separate entity type. So as you can see, there's often no right or wrong answer. It always depends on our use case and on the whole model. Okay, so but I think it's fine if we just model it as an attribute. From this situation 1 description, we cannot infer that we need the office for anything else. Okay, are there any more questions regarding the first situation?